Welcome to the very last lesson from Outcome 30.6, Lesson 8. In this unit, or in this lesson, we are going to start looking at how we can use permutations and combinations to solve some probability type questions. So on your rubric, they are typically level 4 type questions along with others. So again, we're going to try to solve some probability questions. Remember, whenever you're trying to figure out probability, you always put the total number of things that you want on top, whatever you're looking for, over the grand total number of options. So basically in these probability type questions, it's two questions in one. You're finding the probability of what you want first, then you're finding the probability without restrictions second, and then making it into a fraction for probability. So here is the first example. Ari, Ben, Cam, and Dan booked a flight to Florida. The airplane has 4 seats in a row, and they're planning to sit in the same row. What is the probability that Cam and Dan are going to be sitting together on the same side of the plane? So again, when I do probability, I put what I want on top and the grand total number of options on the bottom. So let's start with what I want. I want Cam and Dan to sit together. So again, when I'm ordering people in a row, I start with the fundamental counting principle. And I always start with my restriction, Cam and Dan. So let's say I'm going to start with Cam. Cam walks onto the plane, and he has 4 different seats available to him. And he picks one. Now, Dan is my next restriction. Dan has to sit next to Cam. He's only got one option. Now, Ari comes on the plane. Well, there's 2 seats left. He's got 2 options, leaving Ben with 1 spot left. There are 8 ways that I can get Cam and Dan to sit together. So when I do this probability, what I want, there's only 8 ways for that to happen. The next option that I got to look for is the total. How many total ways can I arrange like these guys on a plane? No restrictions. So I start with one of them. Let's say Ari. Ari walks on, he's got 4 seats to pick from. Ben walks on, he has 3. Cam has 2, Dan has 1. And that is a grand total of 24 different ways they can sit. So my probability is 8 out of 24, which is 1 over 3 if I reduce. You could change that to a decimal, 0.3 repeating. You could times that by 100 and change it to a percentage and get 33%. Generally, you just want to leave it as a fraction. Make sure you reduce it. I would only change it to a decimal or a percentage if the question asked you to do that. So let's try another one. Paula, Jamie, and Andrea are competing with 7 other girls. So that means that there's 10 girls altogether. They're trying to be on the cross-country team. All the girls have an equal chance of winning the trial race. Determine the probability that Paula, Jamie, and Andrea will be first, second, and third in any order. Well, first, second, third in any order. This question could be read as both a permutation or a combination. Both will actually end up working here. So again, when I'm going to find my probability, it is what I want on the top and what I have for grand total. Now, because it said there's first, second, and third, order is going to matter, so I'm going to use a permutation in this question. So what I want is for those 3 girls to be first, second, and third. So first, second, third. That means I have 3 options for first place. That person will get first, 2 options for second, and 1 option for third. That gives me 6 different ways that Jamie, Andrea, and Paula could be first, second, third. 6 options goes on the top. Now I look for the total number of ways that this could go down. Well, I have 10 people, and they all have the same shot of winning. I need a first, second, third. I need 3 things. And it's an order matter, so permutation. So 10, I got to pick 3. And 10p3 is 720. That is the grand total number of options that I have. So again, I can reduce that, and that reduces to 1 over 120. So again, whenever you're doing probability, you're looking for what you want on the top and the grand total on the bottom. Let's try another. Michael hosts a morning radio show in PA. To advertise his show, he's holding a contest at the Gateway Mall. He spells out Saskatchewan with letter tiles. He then turns the tiles over and mixes them up. He asks Courtney to arrange the tiles in a row and turn them face up. If they spell Saskatchewan, she will win a new car. What is the probability that Courtney will win? Well, again, my probability is what I want over the total. Now, she needs to spell Saskatchewan. There is only one way to spell the word Saskatchewan with those tiles. One way. So that's my want. Now, I look at my total, and I look at all the letters in Saskatchewan. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 letters. And order matters. But I can't use the permutation button because I have repetition. I see that there's 2 S's. I see that there's 3 A's. So I have to use my repetition formula. I have 12 letters, 2 S's, and 3 A's. That is the grand total number of options I have for this. So if I punch that in, I get 39,960,800. That is the bottom number of this probability. It is a super slim chance that Courtney is going to win that car. 1 over nearly 400 million. Sorry, 40 million. All right, and one more example for you on probability. Remembering that whenever we're finding the probability, it is what we want on the top, the grand total on the bottom. So a student council consists of 16 girls and 7 boys. So that means that altogether there are 23 people on the student council. To form a subcommittee, we want 5 students randomly selected. Determine the probability that it's going to be 3 girls and 2 boys. So that's what I want. I want, out of the 16 girls, I want 8. When picking options for a committee, order doesn't matter. So because order does not matter, I am going to use a combination. So it's going to be a C. Now I also want 2 boys, so out of those 7 boys, I want to choose 2. That's what I want to happen. So 16C3, sorry about that. So 16C3 is 560, 7C2 is 21, and 560 times 21 is 11,760. So there's my want. Now I'm going to look for the grand total. The grand total, there's no restrictions of how many boys or how many girls. I just know that there's 23 people, and I need to choose 5. So 23C5 is 33,649. So now when I go in to make my probability, it's what I want on the top, 11,760, over what I have for grand total. And again, I reduce that fraction if I can. In this case, it reduces to 1,059 over 3,059. Now that concludes outcome 30.6 and lesson 8. It's now time to practice 8.